chart talking about Ohm's law.
The current in the resistance directly proportional with the voltage and inversely proportional with the resistance.
Perfect. Current is directly proportional to
With the voltage.
with the voltage.
And inversely proportional.
Inversely proportional to resistance. Yeah, that's. Imagine I had no clue of what electrical is, and if you are telling me this is what Ohm's law is, I have no idea what you explained. So assuming that this person doesn't know anything about voltage, current, and resistance, how would you explain to someone in layman's terms? I'm sure your spouse has asked you, what is voltage? You keep talking about I'm working on 220 volts, isn't it? Or you don't get this question because it's not to their interest. Don't you get this question? What you keep on saying you're working on 120. Well, what is volt? So don't you get this question? How would you explain to someone that doesn't know anything about electrical what is voltage? No idea.
Like water going through a pipe.
It's water off the pipe. Perfect. Is that voltage?
Yes.
So the water is voltage, the pipe is voltage, or the flow is voltage?
The
Oh,
flow.
it's voltage.
Okay. And what is water then?
Pressure.
Pressure. And okay, you're almost there. Keep staying with me. So tell me, if I push this, okay? If I push this, what did I do? I provided a force, right? If I provided a force, the marker moved. What is that movement? Response to the push. What is this push? Called voltage. The response you got because the water moved or the pen moved is what? Current. Because of what? The weight of the marker. So weight of the marker will dictate how far it's going to go and the push itself as well. So with that same push, if I did this, the mug would not move maybe let's say 1 inch, but with the same push the marker will move 10 inches. Why? For the same amount of push, you get more response because weight of that equipment is less, which is called resistance. So the weight of equipment is your resistance. The response you got because the marker moved is called current. The push you gave on that marker is called voltage. Are we good? So please write it down. Ohm's law states that, write down the word Ohm's law. Ohm's law states that Ohm's law states that, English is my second language as well. If you don't understand my accent, make sure you do ask. I don't care if you ask the same thing 10 times. Make sure you understand before you leave this room tonight or at 4:30 when you leave. Okay? Ohm's law states that, I'm going to write down as well. Current in an electrical circuit is directly proportional to applied voltage. Current in an electrical circuit is directly proportional to applied voltage. That means I'm going to draw a nice looking triangle for you guys, okay? This is something called Ohm's law triangle. So, what does Ohm's law triangle give me? Let's say if I know the value of voltage, I don't know current, and I'm given resistance. Some of us are good with math, some of us are not so good. So this triangle will come very handy. What this Ohm's law says that voltage is directly related to our current that we get. The response we get that this marker moved is based on the push that we applied, which is called voltage. So this symbol represents directly proportional. Current is directly proportional to applied voltage. The formula that you want to use, which is called Ohm's law, is V is equal to I times R. What's your name, dear?
Karen.
Karen. Karen, I by R in Ireland? It's called I by R, rather than I times R. Here in Canada, when we say I by R, it's I over R. and then you guys say I by R. V is equal to I by R. Here, I by R means I over R, which is not true. So, let's say if you were given current and resistance, you'll put these two numbers and you'll calculate your voltage. But what if you're given the value of current and all you're looking for is calculation of, or you're calculating, current, and you were given voltage and resistance. So this triangle will come very handy. I'd like you to split it into three boxes, just like how I did. V on top, I and R on bottom. So if I'm looking for voltage, what am I going to do? I'll put my hand on V. What do I see? I times R, which I wrote down right here. If I'm looking for I, I'm going to put my hand on I. What do I get? V over R. So I'm going to go ahead and write down V over R right here. If I'm looking for R, what do I get? I put my hand on R. What do I get? V over I. So V is volts, R is ohms, and I is amps. What does that mean? They're just the unit. Just like age is calculated in years and sugar is calculated in grams, same thing. V is calculated or measured in volts, V for volts. Resistance is measured in ohms, if you want to write it down, and current is measured in amps. Volts is represented by capital V. Ohms is represented by a symbol called omega, and amps is represented by capital A for amps. So this is easy. Why don't we do one thing? I'm going to give you an electrical circuit. What I'd like you to tell me is the unknown. So draw the schematic. I'm going to name this as example 1. Okay, I'll draw the schematic. I'm going to give you a resistance value of 20 ohms. The source voltage is 120. All I need you to find me is load current. You have 30 seconds. Let's go. 6 amps. How did you do, Herman?
Is a V over I.
So
sorry,
I is equal
V
to
over R.
V over R. What
Yeah.
formula did you pick? 1, 2, or 3?
2
Formula number 2. Perfect. So I is equal to
V over R.
V over R. What's your voltage given?
120,
Voltage is 120. What's your resistance given?
20.
So load current is V over R. Voltage is 120. Resistance is 20. What do I get?
6 amps.
6 amps. Perfect. Thank you, Kiran. Just leave the whole box here. Thank you. Come on. So, now let's just take an example from just given value of voltage and resistance. If I ask you, Herman, again, what would happen if I double my voltage to 240? I'm going to use another marker. Let's use a black one to just clear it and draw it. And I'm going to put, what if I change the value to 240 for my source voltage? What would happen to my load current and what would happen to my resistance?
Is that double?
What would happen? Sorry. Let's just name it as, this is my V old. Let's just name V new being 240 volts. If my voltage is 240 and my resistance, do you think my new resistance will get double as well here? The 20 ohm will become 40 ohm? Why would it happen? Take the same light bulb, take it to India. The resistance will change? No. Only voltage will change. That will eventually change the current, which is brightness of that light bulb. Okay? So the resistance new and old will remain the same, which is 20 ohms. Once I have these values, I divide both numbers, voltage and resistance. What do I get for my new current? 240 over 20, which will lead to 20 ohms, which will lead to 12 amps. Good job. So what did we just learn? Go ahead and copy if you want to copy this example. Make it as example A, 1A. In example 1A, draw another circuit. Increase the voltage to 240, how I drew it. And say what would happen to your current? Your current doubles as well. What that really means is when my voltage is doubling, my current doubles along with it. That's why we call it current is directly related to voltage.